we are going to discuss about the application of chemical equilibrium in industry. That how chemical equilibrium is very helpful in industries. Chemical equilibrium means the reaction those are taking place at the equilibrium state. The rate of the reversible reaction is as the rate of forward reaction. When the rate of the forward and the rate of the reversible reaction are equal, then that is the chemical equilibrium. So, how the equilibrium is very helpful in industry. Mind doesn't accept this, that equilibrium will help you, because in a equilibrium we see there is no ending of a chemical reaction. So how we can get more and more product? Because in industries we make up products on a larger scale. So if the chemical is stopped at the equilibrium, the reactants and the products concentration are leveled or balanced. They are going back towards each other. The reactants are moving towards the forward if there is any change in the condition, and the products are moving towards the reactants if there is any change in the conditions. Conditions are what? Temperature, pressure, concentration, volume. So if there is any change in conditions, then equilibrium disturbs. And if equilibrium disturbs, reactant and products try to maintain that equilibrium. They are not losing their equilibrium. They are trying to maintain their equilibrium. So equilibrium reactions, chemical equilibrium reactions are basically the reversible reactions. And these reversible reactions help out to produce a higher yield of products. The most important and the most famous reaction is the formation of ammonia. Let's talk about it. Formation of ammonia from nitrogen and from hydrogen. By nitrogen gas and the hydrogen gas, ammonia gas will be formed. This is a reversible reaction. Chemical equilibrium is maintained. This double arrows are showing that there is a equilibrium. The reaction is reversible. The rate of the forward and the rate of the backward reactions are same. This reaction is named as the synthesis of ammonia by Haber process. This process is Haber's process. Ammonia is synthesized by Haber process. So in a Haber process, what are the conditions? Let's talk about it, that how we get the more yield of ammonia. We can get more yield of ammonia if we are increasing the concentrations of the reactants. Because if the concentrations of the reactants are increased, equilibrium will disturb. So to nullify that disturbance, to undo that change, reactants fastly moving towards the product, making more and more product to maintain the equilibrium again. So if concentration of reactants are increased, the yield of the ammonia will increase. If I remove ammonia from product side, ammonia is forming again and again and I am removing it. So by the removal of ammonia, reactants are reacting because they feel that there is no product, and reactants want to maintain the equilibrium. So reactants are reacting quickly and start making products. So by the help of concentration, we can increase the yield of ammonia. This reaction is exothermic. Delta H for this reaction is minus 92.46 kilojoules per mole. This is exothermic reaction. Delta H is negative, which is representing that the reaction is exothermic. So if the reaction is exothermic, if the reaction itself is exothermic, releasing the heat when the product is formed, so what you can do to increase the yield of the product? You have to decrease the temperature, because reaction is exothermic. Reaction itself releasing energy. So if you increase the temperature, it will not favor the exothermic reaction. Endothermic reactions are favored when you increase the temperature. So you have to decrease the temperature if you want to increase the production of ammonia by Haber process. So decrease of temperature. What we do with the pressure or a volume? What do you think? We have to increase the pressure, because product having less moles and reactants having more moles. Reactants having 4 moles and product having 2 mole. And we know that if we increase the pressure, movement, the equilibrium shift towards that side which having less number of moles. So ammonia having less number of moles, so by the increase of the pressure, reactants will move towards the product. In this way, the yield of the production of the ammonia will increase. So increase of pressure will increase the yield. If you are increasing pressure, the volume will decrease. So you can write it as a fourth condition, decreased volume. They are inversely proportional to each other. Pressure and volume are inversely proportional to each other. So decrease of volume, increase of pressure will increase your ammonia yield. Clear? So these are the main points by which you can increase the yield of the ammonia. If you are increasing temperature, then this reaction will not be favored, because this reaction is also an exothermic reaction. So if you are increasing the temperature, this reaction will not be favored. Another most important thing, if you are decreasing the temperature is decreased. As we know, increase of temperature increase the rate of the reaction. Increase the rate of the reaction. I'm talking about the rate of the reaction, the speed of the reaction. But for this Haber's process, I'm saying that you have to decrease the temperature. If you are decreasing the temperature, then how this reaction will be moved forward? Because decreased temperature decrease the rate of the reaction. Decrease in temperature, decrease rate of reaction. So if the reaction rate is slow, rate of reaction is very slow, how you will get your product quickly? Reaction will be very slow. Slow reaction. It takes many days, many months to be completed, because rate is very slow, because the temperature is very low. So what we can do to reduce this deficiency? We have to add the catalyst. Add catalyst. As we know, catalyst speed up the reaction. So you have to add the catalyst in the reaction. You have to add the catalyst in the reaction. So which catalyst you can use in this Haber's cycle, in this Haber's process? You can use magnesium oxide or aluminum oxide. Any of these you can use. Aluminum oxide or silicon oxide. So you can use any of the catalyst for this Haber cycle. The temperature for this reaction is 400 degrees Celsius. If you are thinking that this temperature is very high and teacher is saying you have to keep the temperature low. Yes, you have to keep the temperature low, and this temperature is low for this reaction. Chemical reaction takes place at 2000, 5000 degrees Celsius temperatures. They need a lot of heat to be take place. And 400 degrees Celsius is comparable, is very low. This reaction can be takes place at 200 degrees Celsius. This reaction can be takes place at 300 degrees Celsius. If you are changing the temperature, their equilibrium constant will be changed. Their equilibrium constant will be changed. Clear? So there is the highest equilibrium constant value at 200 degrees Celsius. Highest equilibrium constant value at 200 degrees Celsius. But we are not doing this reaction at 200 degrees Celsius because 200 degrees Celsius is very low temperature for this reaction. This reaction will not be favorable on this temperature. It will be very, very slow. So we keep the temperature 400 degrees Celsius to proceed this reaction for the formation of ammonia. This is the synthesis of ammonia by Haber's process. We do this reaction on 200 to 300 atm pressure. 200 to 300 atmospheric pressure is used to form the more yield of ammonia. So these are the important points of this Haber's process, and remember Haber process is the synthesis of ammonia. There are some applications of Haber's process. Applications are basically related to the ammonia because by Haber's process we are forming ammonia. So if the yield of the ammonia is increased in the industries, that is very useful. Ammonia is used in fertilizers, so that's why ammonia is very important. Ammonia is used in explosives. Explosives are formed by the use of the ammonia. So that's why it is very important. Polymers, nylon, these things are also produced by ammonia. So ammonia is very, very important, and annually 110 million tons of ammonia formed. Annually 110 million tons of ammonia are produced in the industries. Next is contact process. What is contact process? Contact process, keep these all things in your mind. Contact process having the same conditions. Let's see. Next is contact process. We are discussing about the application of equilibrium constant in industries. First we have discussed about the Haber's process. Next we are discussing about the contact process. Contact process. Contact process is the synthesis of sulfur trioxide. Let's see. SO2 plus O2 reacts. This reaction is reversible. Sulfur trioxide will form, balance the equation, 2, 2. This is also an exothermic reaction. Delta H for this reaction is minus 194 kilojoules per mole. This reaction is also exothermic reaction. Heat is released during. So how we can increase the yield of sulfur trioxide? First, if you are increasing the concentrations of reactants, if the concentrations of reactants are increased, then equilibrium will disturb. And reactants want to undo that change. How reactants can nullify or undo that change? By moving towards the product, by making more and more product. So in this way we get more yield of sulfur trioxide. By the removal of sulfur trioxide. Sulfur trioxide is forming in a chemical reaction and I am quickly removing this. So if I am removing the product, reactant will feel the equilibrium is disturbed. So they are reacting together quickly and making product more and more. So in this way, production, the yield of sulfur trioxide will increase by the removal of product. Product is sulfur trioxide. Next, the reaction is exothermic. So how I can increase the yield? By decreasing the temperature. By decreasing the temperature, as I have discussed later. If I am decreasing the temperature, then reaction is favored. Why? Because reaction is exothermic. Reaction is exothermic. If the reaction is endothermic, then those reaction will be favored by the increase of the temperature. If you see in exam or in any MCQs that the reaction is endothermic, so that reaction will be favored if you are increasing the temperature. So keep in mind. Third, what happened by the increase of or decrease of the pressure? You can see here reactants having 3 moles, product having 2 moles. So as we know, by the increase of the pressure, equilibrium shift towards that side which having less mole. So product having less moles, 2 moles. So if I increase the pressure, the equilibrium will shift towards the product forward. So in this way, yield of sulfur trioxide will increase. So I have to increase the pressure to increase the yield. If pressure is increased, which means volume is decreased. So if the volume is decreased, it looks like the number of moles per unit volume are increased. So reactants feel that their number of moles are increased, so then they start moving towards the product. They feel that their number of moles are increased, but actually this is not happening. Their number of moles are increased per unit volume, but they disturbed by this change. So when they feel disturbance, they try to undo that disturbance. They try to decrease their mole. So they start moving towards the product. In this way, yield of sulfur trioxide is increased. Next, as I said earlier, if you are decreasing the temperature, then reaction is very slow. By the decrease of temperature, reaction becomes very slow, because as we know, if the temperature increase, reaction rate increases. So if temperature is decreased, rate of reaction is decreases. Rate decreases, reaction is very slow. So if the reaction is very slow, it takes many days to make a product. But we need a large amount of product. We need a highest yield of the product. So what we have to do? We have to add the catalyst. We have to add the catalyst. Catalyst will speed up the reaction without affecting the reactants and the product's concentration. Catalysts do not react with the reactant. Catalysts do not react with the product. Not all the catalyst. We have to choose the catalyst. We have to choose the specific catalyst, that catalyst which do not react with the reactants and the products. So for this contact process, the catalyst which we used is vanadium pentoxide, V2O5. This catalyst is used, or you can also use finely divided platinum. Symbol is Pt. So this is the element, basically platinum. So you can use this element, finely divided this element. This element increase the reaction, increase the contact process, increase the production of sulfur trioxide. Sulfur trioxide, this is just for the general knowledge or for your MCQs. You have to learn about on which temperature this reaction will take place, on which temperature Haber's process will take place. As I told you that Haber process takes place at 400 degrees Celsius, and pressure will be 200 to 300 atm, and this contact process takes place at 400 to 500 degrees. These are the things that can be asked in MCQs, or these are the things that you must know when you are writing, because when you are writing something, you are writing about any type, you have to write all the important information. Clear? So the use of the sulfur trioxide is, if you are dissolving the sulfur trioxide in H2SO4, it will give you oleum. Oleum is H2S2O7. This is oleum. So when sulfur trioxide react with H2SO4, you will get oleum. And if you want to get back H2SO4, so you have to dilute it into water. then you will again get sulfuric acid.